Yes.
record? Okay, that's recording.
Can you guys hear me?
Yes.
Like I can show you what I found and why this PR is failing.
Okay. Shall we switch over to you sharing your screen then? Would that be more convenient, or do you want to tell me what to do?
I can tell you what to do, or like it both works for me.
Okay. I mean, as I'm already sharing, if you want to tell me what to do.
Let me just open.
And if it becomes too awkward, we can switch over to you.
Just open the branch. If you open the test file that you are using to
Okay, so we'd made a couple of modifications to it yesterday. So should we maybe make it go as it was?
no, that's okay. If
Okay.
you return b of 0, b of 0 works.
So the thing is, one of the things we did was change so that B wasn't reassigned. So shall I put that back to B there?
That's okay. So return c of 0.
Or return C of 0? Well, so I think that is now equivalent to what you had in the first place. So if we try that, then.
Oh wait, was it supposed to be B of 1? I think it was supposed to be B of 1. Do you want to select the row that is being broadcast?
Yeah, I think Guillaume just instructed me to return B of 0 because that does work.
Oh, okay.
But so I think what we should see is if I change that to B of 1, then it won't work. Is that correct?
Won't work. Yeah.
Okay, let's just check.
So the
oh yeah. Okay. Yes.
my suspect is that when you return b of 1, you're returning, you're actually accessing a memory that is invalid.
Yeah.
The base pointer is invalid. The base pointer to compute the index, like the slicing, is invalid.
So I think what we saw yesterday, if we were running, have you run number stuff under Valgrind before? Guillaume, have you run number stuff under Valgrind before?
I never, like I don't have Valorant on my computer.
Okay, so what we did see yesterday when we ran it under Valgrind was, it takes a minute to run, but we do see it accessing an invalid value or an invalid location, either inside the jitted function or returning from boxing the thing that you're returning, or sometimes printing it out, depending on exactly what happens at the time you run it. When we stopped on in the debugger on that particular bad access, what we saw was that the array structure seemed to have a shape and strides of 0, and the data pointer was also 0, although we don't seem to be getting that error this time. What I might do is just rebuild number for debug. Oops. Try that again. Had you had any other thoughts or insights by now, or was that the kind of the main thing that you were showing us?
I have one other thing, but I'm looking at my stashes here to see if I can find it.
Okay. Ah, that's frustrating.
Oh, what is it?
It appeared to work. I rebuilt Numba with no optimization with debug, and it's not only produced the correct answer, it's also not hit an invalid access.
So you think it is the reference counting stuff or an optimization? But that'd be kind of weird because you've been running it with all the same optimizations, even in debug, right?
Yeah, the only thing that's debug, that's built for debug is the C extension parts of Numba. So the stuff that does the Numba runtime boxing and unboxing, like converting Numba reference counts to Python reference counts, and the bit that dispatches the jitted functions. We're still compiling. Numba is still jitting things with optimization.
Yeah. Maybe it was the rebase. Well, I don't know. You just reproduced the error a second ago, right?
I did, yeah. Yeah, that was with the. Well, I wasn't running the Valgrind, I don't think, though. That can also have a bit of a knock-on effect. Yeah.
Well, that worked.
Oh, look, I'm an idiot and I'm running the wrong file. That's the problem.
Oh, yeah. Okay.
Oh, sorry. Try that again.
So, I mean, I'm looking over the broadcast 2 shape, the IR, generation stuff that's going on there. And yeah, where we left off last time was, maybe the shape strides aren't being computed correctly, but I don't think that's necessarily the case. Otherwise, I don't know. Have we tried this without the read-only?
Without what?
I just found it.
Without the read-only parts. But Guillermo, you said you found the issue.
So can you open the array object.py file?
Yeah. Is that in core or is it in NP, or I've forgotten where it is?
It's an NP.
All right,
Number NP array object.
NP array object.
Okay. Yep.
Okay, go to line 407.
Okay.
The problem is in this basic indexing file, basic indexing call, line 414.
Okay.
If you
Oh, sorry, you say 414? Yes.
printf, like you cg.utils.printf, this data pointer, there is an offset between returning b of 0 and b of 1. And this offset is exactly the size of the you're using inter2. is exactly the size of the two elements of B of 0.
Right. Whereas you would probably want, you don't want it to be offset at all, is that right? Because you're returning, no, what?
Because it's a view. Guess the base pointer for computing the get item should be always B rather than B plus an offset.
Yeah.
Well, I guess, yeah, I mean, the question is, in NumPy, when you do get item for a view, it does this logic separately, or does it not? I don't really know.
Yeah, I don't know either. So I'm just guessing here.
So if we,
in this test case, if you return B of 0 and B of 1, and printf the data pointer, you will see the
if we do this without number,
Oh, it'll definitely work without number, yeah.
oh yeah, yeah. What I wonder is,
oh, you're gonna look
so,
at the actual. I see. Okay.
yeah. Yeah, all right. So so B and new B both have the same base pointer. Yeah.
Well, what is the other field for? True and false? Is it like read only or something?
Probably. Let me have a quick look. Oops. I'm actually going to look at the CUDA array interface documentation because I know that's copied the NumPy array interface. Data integer boolean for second is, yeah, read only. Yes, exactly.
So in strides, none here?
I guess strides is only none if, I guess
if it is contig.
Oh, seriously? Okay.
Yeah. If you essentially, if you don't need the strides, you can just do this. If strides is none, then you can do more simple calculations just based on the shape and date item size.
All right, so we got to get the result of make array to point to the original, that structure to point to the original data.
Yeah. Whereas in the implementation of broadcast 2, is it this BC or just where is the data pointer getting adjusted?
The copy part, or actually, I don't know what that copy does. Yeah, well, it's just for the type, right?
Yeah, then we make that an array and then we pack shape strides. What is this function just up here?
Oh yeah, that's just all the broadcasting logic.
Yeah, okay. And this, I think, is this something different now? No, maybe copy source.
Wait, is it using maybe copy source?
I don't know. Let's have, well, let's just quickly check.
Because that function seems to be doing something with the data. But no.
No, it comes from fancy set slice, unless we're using fancy set slice, which I think we're probably not. Oh.
So is that it? Do we just need to copy a pointer to the data field in that structure and broadcast to shape? Seems a little odd that it still works when you don't index though.
Yeah, I've just realized we've tested that without JIT, but we haven't actually printed out things with JIT. So if we break here and just print those same things out with the number version, then what was it? It was B, wasn't it? Yeah, so that is exactly 8 bytes along, isn't it? Sorry, 16 bytes along, which is the entire array along.
Oh, it's okay. So the new one, that's the view that's produced, is 8 bytes ahead of the original data pointer.
Yeah.
Oh yeah, okay, I see. Yeah, because new B is, yeah, it's the result of the indexing. All right, yeah, sorry.
Yeah. It is correctly read only though, which is
Oh yeah,
something.
yeah. Jeremy added logic to that, right? Specifically, I think.
I feel like maybe for this B, I am curious what its strides are, because it won't be C contiguous because you've got a repeated index in this way. So strides should not be none. So if we quit this and go back to repro 3, we'll just break up here. And then B.array interface. Yeah, it's got strides of 0, 8. So essentially don't stride for the first dimension, just go back and repeat over the array. Then if we investigate whether it's the same with number or different, that might point to why we've got a problem. So I think what we'll have to do here is return B and B1. So I guess my hypothesis is that B cast B is going to have strides of none when it should have strides of 0, 8. Oh, it does have the correct strides. Okay. So then not only does it have weirdly though, it's and then B's array interface. Sorry, everything's running off the screen, but the B and the broadcast B, they are sharing the same data pointer, so that's correct.
Mhm.
The broadcast B has got the correct strides, which means it's this indexing operation which is not working correctly, which is kind of what Guillaume said a little earlier. Online, was it 414? Like this,
So-
this basic, maybe this basic indexing doesn't take account of strides.
So yeah, my question before was in the actual NumPy code. Yeah, if the indexing functions themselves do have special logic specifically for views, or if that's supposed to be handled some other way. But if that's the case, yeah.
I guess one thing that could happen is if this, I wonder what the type of this B is. This B should be typed with the A order to force Numba to use the strides for any computation. If it's accidentally been typed as C order, then it won't. So what I'd think about doing next is seeing what the typing of this function is. So comment out that breakpoint and what was I doing again? Oh yeah. Oh, sorry, just a moment. I just need to rerun develop so that it installs the exact right version in, otherwise the Numba binary version check fusses. Right, so why didn't I get any HTML out of that? Is that maybe why? No, whoops. Oh dear. Okay, I've accidentally obliterated the reproducer. Sorry. So that should have had might use help, see how to use this right. So that should be annotate HTML, repro2.html, repro2.py. So function is here and it's typed. Ah, look, it thinks it's C ordering, which will lead it to ignore the strides. So that should have been typed as an A ordering. I think that should have been typed as an A ordering because then it wouldn't ignore. So I think this means that there's a problem with the typing of the broadcast implementation. So let me just have a quick look at where that is. Oh, in array obst.py. Let me just close that so I've got a bit more space. What was it? Don't need to fall in. There we are. So
One. It's all right.
Here we are.
Yeah, this line.
Yeah, so instead this one, what are you going to say? Yeah, so I think if you're broadcasting, you probably always want to be see, it just occurs to me that I'm not entirely sure what array.layout looks like. I think it should just be a character, but I'm not sure. So I'll just print it out quickly.
Yeah, it's a single character string.
Okay. All right, let's just put A here then. that does seem to give the correct answer.
Oh.
So what do we think about where to go from here?
I mean, is there any reason not to fix the layout like that?
There's possibly cases when this is slightly less than optimal. I mean, obviously, it's always better to be correct first and then worry about optimizing it later. Doesn't matter how fast you can do the wrong thing.
Yeah, in NumPy, it looks like the result is also at least C contiguous, F contiguous are both false, right? Yeah, it looks like it. I don't know if that. Hold on.
I guess what you could, no, because you have to figure out the return type before you. The thing is, you don't know what values you're broadcasting with, so you can't at this point. Here's the typing point, which is happening before the code gen function is called. So you can't just do a quick check to see whether you're actually going to end up with something C contiguous or not from the arguments. So at least as an initial fix, I'm struggling to see a direction beyond here, apart from going and trying out implementing a bunch of test cases. Is Sue still on the call?
Yeah.
Hiya. Yeah. I feel like if there's something more, then you'll be seeing it.
Yeah, I think the logic you're going with is right. That you cannot predict. This is a typing. You cannot see what shape it, so you couldn't have guessed it. That it could have returned something more optimal. So it would have to go for the A layout.
Yeah.
My only question would be is how much concordance with NumPy we'd be going for here. So if that's the case, it does look like you get roughly the same result in NumPy when you broadcast.
Right. As soon as you have any zeros in your strides, it's A layout. It cannot be C or F. So the only possible optimization I could imagine here is if you somehow discover that the argument shape matches the original shape and you can return the original layout. Otherwise, I cannot see any other cases where you can return any contiguous.
That's what NumPy does as well.
Mm-hmm.
Yeah.
I should think that most of the time people are broadcasting, they would be expecting that you wouldn't be broadcasting if you didn't need something that didn't end up with this layout.
I can tell you from our situation, it's possible. I mean, it's something, again, we would optimize out from a symbolic graph side of things, but again, the automation level of just applying these operators, I can see it happening.
Okay, right, I take your point.
Yeah, that's a tricky one because, again, I'm speaking only about the context in which we're using this.
Yeah,
anyone
but-
writing things by hand would hopefully never do that.
Yeah, but then we ought to think about people like you who may not necessarily be writing things by hand.
Yeah, or in any case where you would have a function that its arguments are the shapes somehow. You know, some derived calculation where this wouldn't be clear down the road. Actually,
Yeah.
I wonder if that's plausible. Well. Yeah, but you couldn't do that symbolically, right? Like at the point inside of the intrinsic for NumPy for the broadcast 2, you wouldn't, unless the shape was, you know, literal values or something like that, or were entirely inferred as constants, you wouldn't even be able to make that comparison, right?
Yeah. So I will have to wrap up myself in a few minutes anyway. Is there anything productive or helpful that we could do with, say, 10 minutes of time we've got left? Any questions or anything else anyone wants to have a look at?
I mean, I'm good. This was, again, this a great demonstration for debugging, especially with the use of Valgrind and all that. That's something I'll definitely be using.
Okay.
Oh, and the HTML annotation stuff. I don't think I've used that before.
Oh yeah, it's really useful for. I don't think I could. Well, I don't think I could cope with debugging the typing without the HTML annotations.
Yeah, that's all for me. Anything else would just be, you know, moving on to a different thing. Like we wanted to dig into the vectorized stuff, the LLVM optimizations that are and aren't being applied.
Shall we make arrangements to have another discussion about that at a later date then?
I'm down for it.
Okay. All right then. If there's nothing else, I guess we'll let everyone else get their time back. Thanks for Guillaume. Are you happy with what you see? Is there any more info you want?
That's okay. That's okay from my side.
Okay, cool. All right then. All right. Thanks for joining everyone, and probably speak to you on Gitter.
Sounds good. Thanks again.
Thank you.
Thank you, Graham.
Thanks. Bye. How do I stop everything?